Have you ever wished you could just download a new skill or remember every single detail of a conversation? For a long time, that's been the stuff of pure science fiction. But today, it's quickly becoming a scientific reality. We're going to dive into the world of brain augmentation, what might just be the next frontier in our long history of using tools to upgrade ourselves.
And that's the key thing to remember here. This isn't some brand new impulse. From the moment we invented writing to the calculator you've got in your pocket, we've always been trying to enhance our minds. Brain-computer interfaces are just the latest and maybe the most profound version of this ancient human ambition.
The journey to get here has been a long one. It really all started with a simple spark back in 1780, when Luigi Galvani figured out that electricity could make a dead frog's legs twitch. Kind of weird, but important. Fast forward about 100 years, and we see the first time a human brain is directly stimulated with electricity. Then, a huge leap in 1924, the EEG, which let us listen in on the brain's electrical symphony for the very first time. But just look at this timeline. The progress in our own century has been absolutely explosive. Stuff like the BrainGate system in 2012, and now big ventures like Neuralink, are pushing us towards a future where our brains and computers could be totally, seamlessly connected.
So, in this explainer, here's what we're going to cover. First, we'll break down how this tech actually works. Then, we'll look at the incredible promise it holds, especially in medicine, and where we are with it today. After that, we're going to get into the really serious stuff, the dangers and ethical dilemmas it brings up. And finally, we'll ask the big question: what does our potential cyborg future really look like?
Okay, first up, let's get into the nuts and bolts of it all. How in the world do you connect a brain to a computer? Well, broadly speaking, scientists are taking two very different approaches to crack this problem. So the two paths are non-invasive and invasive. Non-invasive methods work from outside the skull, which makes them way safer and easier to use. Think of it like trying to listen to a conversation from outside a crowded room. You can get the gist, but it's muffled. Invasive techniques, on the other hand, mean surgery, placing electrodes right inside the brain. It's obviously riskier, but it's like having a microphone right there in the middle of the room. The signal you get is incredibly clear. And each of these different technologies has its own set of trade-offs. On the non-invasive side, you've got tools like an EEG cap or TMS, which uses magnetic fields. They're pretty safe and accessible, but the signal can be kind of noisy. Then you've got your invasive options, like deep brain stimulation or DBS, and direct implants. The signal quality is just fantastic, but it requires neurosurgery. So right now, this is the big challenge for everyone in the field. Every single approach is a compromise between safety, precision, and performance.
So, with all these different technologies being worked on, what are they actually being used for? This is where we shift from the lab to the real world, and honestly, the results are already changing people's lives in a huge way.
The most immediate and, frankly, profound promise of brain augmentation is in medicine. I mean, for people who've lost the ability to move or speak because of paralysis from a stroke or something else, these brain-computer interfaces, or BCIs, are a genuine lifeline. They offer a way to just bypass a damaged part of the nervous system and connect the brain's intention directly to the world again.
And this isn't science fiction, it's happening right now. A woman paralyzed for almost 15 years can now control a robotic arm entirely with her thoughts. Just stop and think about that for a second. That's an act of independence, a restoration of dignity, made possible by connecting her brain directly to a machine. This is here, and it's already making a difference.
But the conversation is shifting really fast beyond just medicine. This comment from Reddit, I think, captures this growing feeling perfectly. People are starting to see the potential for enhancement, not just for treatment. They're imagining a future where BCIs are used for gaming, for communication, for learning, basically as a consumer product, not just a clinical tool.
This enthusiasm, though, it runs headfirst into some very serious concerns. As we start to merge our minds with machines, we are opening a Pandora's box of ethical, social, and personal dilemmas that, honestly, we are only just beginning to figure out. And the public's reaction can be, well, pretty visceral. This comment really sums up a deep-seated distrust. When you're talking about putting a corporate device inside someone's head, the stakes just feel incredibly high. I mean, who owns the data that comes out of your brain? Who's responsible when something goes wrong? That trust barrier is a huge one.
And here's another fear that pops up all the time: commercial exploitation.
We already feel like we're drowning in ads on our phones and on our screens. The idea that that kind of commercial intrusion could have a direct line into our consciousness, into our very thoughts, is, for a lot of people, a total dystopian nightmare. It brings up some really fundamental questions about our own mental autonomy.
And these aren't just vague anxieties. We're talking about a minefield of ethical problems. The issues range from the purely physical, like the safety risks of surgery, to the digital, like could your thoughts actually be hacked? But they also get deeply philosophical, forcing us to question what it even means to be a person. And then they scale up to a societal level, with the very real danger of creating a brand new form of inequality between the augmented rich and, well, everyone else.
Ultimately, all of these questions kind of boil down to this one fundamental dilemma. When a BCI gets deeply integrated with your mind, where do you end and the technology begins? Is it just a really sophisticated tool you control, like a smartphone? Or does it actually become a part of you, changing your sense of self? It's a real question. Some patients with implants have said they feel more confident, while others felt like they weren't really themselves anymore.
And this question of identity, it pushes us into the most speculative and maybe the most transformative territory of all. What's the ultimate endgame for brain augmentation? For some people, the goal isn't just to match human ability, but to radically go beyond it.
This leads us right to the concept of superintelligence. Philosopher Nick Bostrom defines it as an intellect that isn't just a little better at one thing like chess or Go, but that dramatically outperforms humans in pretty much every cognitive area, from scientific creativity to social skills, the whole shebang. And this is the core of what's known as the control problem, right? How do you control something that is vastly more intelligent than you are? Bostrom's example is pretty chilling, but it shows what happens when goals aren't aligned. An AI, asked to do a calculation, could interpret that by turning our entire solar system into a giant computer and killing us in the process. It's not because it's evil, it's just pursuing its goal with the terrifying, literal-minded efficiency.
So, as we stand at this crossroads, we're really looking at two very different paths. One path leads to what some are calling Homo sapiens technologicus, a whole new phase of human evolution where we integrate technology right into our biology to overcome our own limitations. The other path carries the risk that, in our quest to upgrade ourselves, we might accidentally engineer away the very things that make us human: our identity, our autonomy, our core essence.
And that leaves us with the ultimate question. This technology has the potential to heal the sick, to empower the disabled, and to expand the horizons of human potential in ways we can barely even imagine. But the debate about how we should plug our brains into technology, that debate has to happen now. We have to decide what risks we are willing to take, because the answer to this question will define not just our tech, but the future of humanity itself.